we are at North Webster High School to explain to you Newton's 3 laws. Here we are at North Webster High School bathrooms to explain to you Newton's first law. So Newton's first law states that an object will move at a constant velocity until a force acts on it. So basically what that means is that objects won't stop or start moving until a force causes that to happen. So the main deal that you need to know about Newton's first law is inertia. That is the tendency of an object to resist a change in motion. And inertia scales with mass. So basically, the greater mass something has, the more inertia it's going to have. And with that being said, let's move on to our demonstration. Here we are in North Webster High School hallway to demonstrate to you Newton's first law. Yup, here it is, Newton's first law. As you can see, the inertia of these chairs causes them to not move. They're not moving unless I push them. That chair didn't have much inertia at all. But this chair with this fat guy in it has a lot of inertia because he's so massive. Ta-da! Here we are at North Webster High School in Principal Lyons' office to explain to you Newton's second law. So, Newton's second law states that a net force acting on an object causes that object to accelerate in the direction of the net force. So what this basically means is that when a force pushes or pulls something, it'll move in the direction of that push or pull. So this can be summarized in a basic equation of force equals mass times acceleration, or F equals ma. So let's say that we kicked a ball, right? And we know how heavy it was and how fast it went, but we want to know how much force we used to kick that ball. So all we got to do is multiply our mass, 2 kilograms for the ball, and our speed of it, 5 meters per second squared. Together, 2 times 5 is 10. We know that 10 newtons of force was used to kick the ball. And with that being said, let's move on to our demonstration. Here we are at North Webster High School Little Gym, the big gym was occupied, to demonstrate to you Newton's second law. So, if I get this totally normal basketball, nothing weird about it, and hit it with this baseball bat, it moves in the direction of the net force. And if I get this other totally normal basketball and hit it even harder, what I meant to say was, I get this other totally normal basketball and hit it even harder, it goes even faster with greater acceleration because of the increased force. Ta-da! Sure was a nice nap. Now, here we are at North Webster High School dumpsters to explain to you Newton's third law. So, Newton's third law states that for every action, there's an equal and opposite reaction. That basically means that when a force pushes or pulls on something, that thing will actually push back in the opposite direction with the same amount of force. So basically, if I push down on something, it'll push back up in reaction. With that being said, let's get on to our demonstration. Here we are at North Webster High School attic to demonstrate to you Newton's third law. So watch as I jump. There it is, Newton's third law. To jump, I had to push myself down into the ground. And the ground, using an equal and opposite reaction, pushed me back up in order to send me into the air. Only with that equal and opposite reaction was I able to go up. And if I use more force on the ground, I jump higher because the reaction was equaler and oppositer. And with that being said, conclusion. Here we are at North Webster High School parking lot in the back of the French teacher's car. I hope you've learned more about Newton's 3 laws as we journeyed around North Webster High School's most pristine and prestigious locations. And with that being said, farewell.